So, dear colleagues and friends, I hope that you enjoyed the Academy's hospitality, which is a fantastic way also to make science easier. No bomb here. It's Lee? I was speaking about hospitality, you see. It's a relative way to organize the things. So next speaker will be Professor Zeresemai, and not Zerai, Zeresemai Alemseged. So it's a story. I know Zeresemai since a very long time. He came to Paris and did his PhDs in Paris, and I was chairing his PhD as I'm chairing his talk today. I'm very happy to see him again. And he did, as you know, fantastic discoveries. After his PhD, he got a permit to work in Afar, in Dikika, which was so close to Hadar that it was a sort of Hadar complement, Hadar connection, Hadar something. And he found the girl, the daughter of Lucy itself, that he called Selam. And he showed me yesterday a fantastic, beautiful, well, I would, no, I'm not allowed to tell you what. Beautiful something that he found recently, and which is also really, really fantastic. So, Alemseged, 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 please, you have the floor.
Merci, Monsieur le Professeur. Je suis aussi ravi de vous voir aujourd'hui et tous mes amis français. I would like to start by saying thank you to the Pontifical Academy of Sciences for giving me the opportunity to share some of the things that I'm very passionate about. Okay, there is some technical issue, but that's fine. The title was the significance of the Dikika marks beyond the cuts. I hope that will not continue to happen. But we're asked here, challenged in a way, to talk about who, what, where, when, and if there is anything, I think, exciting, there is some of the exciting things in human evolution are who made the first tools, who used the first tools, stone tools, and who used those tools to exploit meat or bone marrow in the history of humanity. Those are some of the fundamental questions. And I think I'm invited to speak about that because back in 2010, we published a paper that claimed, major claim was it, that we have the evidence at around 3.9. Oh, okay, so this is the right slide. As Professor Coppens mentioned, I worked at Dikika for some time now, and you may know the site because of the discovery of Salam, or the Dikika child, the earliest skeleton of a child dated back to 3.3 million years ago. And we continue to work there, and as you can see, we have been very successful in publishing extensively, and we also actually have new specimens that are yet to be published, so stay tuned. But today I'm not going to talk about the skeleton, but a topic that would delve into the origin of stone tool use and stone tool making. So why is the advent of stone tool use or making a milestone in human evolution? Well, because if you're using stone tools as opposed to interacting with nature with your hands or teeth, the quality and quantity of resources that you acquire are going to be different. And if you do that, then the pre-ingestion food processing is going to externalize your digestion. You're going to digest before you even swallow. So that's a fantastic thing that happens if you're using stone tools. And if you do that, you are also going to have a very different interaction with other species and your environment. And that will determine the within group or within species interaction as well, because the networking that you need to use stone tools and scavenge is not going to be the same if you were to simply go out and forage. But don't other animals use tools? Well, the answer is yes, but no animal, including chimpanzees, has been observed knapping stone tools the way we do it to make it sharp so that you can exploit meat. And meat consumption, as you know, in chimps does exist, but it's happened in a very different way. They devour a little colubrine in a savage way, and you don't really see them systematically exploiting meat using sharp-edged stone tools. So the role of stone tools in defining humanness has been really very key, and stone tool use actually for Louis Leakey was very fundamental in how he articulated the questions, and that seems to have a very lasting impact on how we think of stone tools today. For him, stone tools were fossilized human behavior. And he said man, the tool maker, was a very key definition that he had, which led to people like Kenneth Oakley to suggest that if man is defined as a tool-making animal, as claimed by Louis Leakey, then the problem of the antiquity of man resolves itself into the question of the geological age of the earliest known stone tools. So that definition, not only is it going to impact our thinking of what makes a human human, but also its antiquity. And therefore, it was a big surprise when Jane Goodall started to find human behaviors, including tool use, in chimpanzees, who actually was sort of mentored by Louis Leakey. And then when he heard news of those discoveries, Louis said, now we must redefine tool, redefine man, or accept chimpanzees as humans. And you can see how mechanistically Louis Leakey and his colleagues are really struggling to define what makes us human. And I like this part particularly, where he says, if tool making no longer separated Pan from Homo, then certainly, I like the certainty, by the way, an extinct human ancestor with nearly twice the brain of a chimp, and he's referring to early hominins, cognitive ability, and manual dexterity to make flagged stone tools was man enough. So not yet there, but man enough to be included in our genus. Again, this takes back to how Louis Leakey saw hominins. But there were people who politely showed some dissent, and one of my favorite guys is John Napier, who actually worked with Louis Leakey, and he did not see a big gap between humans and chimpanzees in terms of tool use and tool making. And he says it's really a very short step from tool using to tool modifying. In a sense, stripping twigs or leaves from a branch in order to improve its effectiveness as a tool or weapon. And he continues, it is an equally short further step to tool making, which at its most primitive is simply the application of the principle of modification to a stick, stone, or a bone. So that is basically to give you the struggle that paleoanthropologist has had in defining what makes us human as it pertains to stone tools. But this is really my favorite, and comes from John Napier again, where he says, modern man must recover from his surprise as a discovery that hands other than his own were capable of shaping tools. So for him, you don't need the human hand to make stone tools, to use stone tools. And this really is very revealing of the conversation these guys had. And therefore, where in 1964, Louis Leakey and his friends, including Napier, published the paper on Homo habilis, naming him Homo habilis, the handyman. They say, while it is possible that Paranthropus boisei, in their view, a more primitive species, and Homo habilis, both made stone tools, so they accept it. And yet, they say it's probable that Homo habilis was the more advanced tool maker, and that Paranthropus boisei was the intruder or the victim. This is fascinating because it sort of mimics what Raymond Dart was saying about the caves in South Africa with his osteodontoceramic culture. He saw the early hominins as flesh-loving, bloodthirsty creatures that would then kill and eat those species that were encountered in the cave. The fact As we know from Bob Brain's work, however, was the other way around. Actually, the hominins were the hunted and not the hunters. So given that background, I wanted to put things in the context of the historical background, who, what, where, when, question who is the earliest tool using making hominin species in our lineage. And I'm going back all the way to even species like Ardipithecus or Sahelanthropus. Who can make those tools and who is a tool user? Well, we first have what I call the implicit hypothesis. When you name your species Homo habilis, the handyman, you're basically equating Homo to tools. And things also seem to make sense, because up until 2015, we had the stone tools dated at 2.5 million years old that come from Gona, suggesting indeed there is a correlation between the emergence of Homo and stone tool emergence. The same thing with the cut-marked bones that suggest that someone was using sharp-edged stone tools to carve meat of the bone or access the bone marrow. So both the archaeological record and the record for the cut-marked bones up until 2010 suggested some correlation between the emergence of Homo and then tool use, sort of supporting the implicit hypothesis that Lewis and his colleagues had about the relationship between being human and stone tool use. So that's where then our discovery comes. We published back in 2010 cut-marked bones that date back to 3.9 million years ago. No, 3.39 million, let's say 3.4 for simplicity reasons, and claimed that the antiquity of both stone tool use and stone tool use, therefore and using it to carve meat of the bone dates back to 3.4, which is a major claim because we're pushing the date by 800,000 years than previously thought. And what did we do? This is a picture of Dakika. You see the picture of Salam there to show you where she came from. And the bones that I'm going to talk about come from right here, which is only 200 meters away. And what you have there are fluvial sediments or lacustrine sediments that where you find all the famous fossils that you know of, be it at Hadar or at Dakika. So what we did at that point is we started a new type of bone collection at selected sites. Many of us, like myself, when we do the traditional way of paleoanthropological search, you cannot possibly collect all the bones that you have on the landscape. So what we do is we separate what we call collectible versus non-collectible. What are collectible? Those that are diagnostic for taxonomic purposes. They could be teeth, they could be part of the skull, the jaw, or long bone extremities. We call them collectible. The things like the shaft of a bone in the ribs, because you don't really know where they come from, you wouldn't normally pick them up. So what we said back in 2008, I think was, well, if we were to recover every single bone from a selected site, like we're doing it here, and you can see it after collections, there is nothing remains, what would you find? And if you were to analyze the bones for bone surface modification, and then you would carefully examine every single bone from that site, and then you go back, that is my second supervisor, Denis Girard, when I worked in France. You would go through all the bones and see if you see bone modification on the bones that you have. And based on that, what we did is we identified some bones and we exported them for further investigation using what we call the scanning electron microscopy. So what you do is, for example, if you see here, you have two marks that seem to be incised, and then this bone is papered with all sorts of marks, the same in here. So these guys were then exported and then examined using scanning electron microscopy. And the big bone here comes from a rib bone of this type of animal, a big cattle, and this one comes from a femur of a goat-sized antelope. In the shaft and the rib are normally things that you would not collect. They fall under the category of non-collectible. But then if you are an early hominin and you want to eat, would you go for the teeth or for the head or for where the muscles are? So that is really an important point to underscore. How old are these bones? Well, the good news in East Africa, and many will agree, is that we have the succession of sediments that are intercalated with volcanic ashes. And many of you know that this is a Sidi Hakoma tuff dated to 3.42, and this is a TT4 tuff dated to 3.24, and the bones come right from within. That's why we know how old they are. They are 3.4 million years old. And they are only, as I said, found only 200 meters, geographically speaking, from where Salam was found. So how do we know? These two marks, and some of these marks are induced or inflicted by an early hominin employing or wielding stone tool or any type of sharp stone. Well, the first thing to do is you use experimental comparative material. In other words, you have a collection of bones that were experimentally, that bear experimentally produced marks like this one. And when you do that, you normally have marks that show deep V-shaped cross sections, and that's what you have here. They are deep V-shaped. And many of the marks here are also deep and V-shaped. But that's criteria number one. That's not enough. We also do what we call characterizing the microstriations. And microstriations are nothing but the fine-grained microscopic features in the marks that can be seen only using scanning electron microscopy, as you can see it here. And what is interesting, and this is published material by Njau, is you can distinguish percussion marks, cut marks, trampling. Trampling means when animals or something walks on the bones while they're on the surface, they can induce marks that could mimic what you may characterize as cut marks. And then you can see what a crocodile microstriations would look. And then here is for mammalian carnivores. So using this reference, which existed already for us, we did the same thing for the Dakika marks. And indeed, the Dakika marks, not only are they deep, incised, V-shaped, but they also contain microstriations. And at that point, when we published the paper back in 2010, these are the criteria that existed for us to be able to evaluate what we had. We also did what is called test by 3 experts, a type of blind test, you can call it. And what you do is you show all the marks that I showed you, and there are 12 of them, and you ask them, what do you think, based on your expert's experience. And 3 of the experts agreed over 98% on 12 what we call high confidence marks. So what you do is, oh, you have this mark, do you think it's a percussion mark or a cut mark, or we don't know what that is. And as you can see, the many marks that I showed you on the picture are now here characterized as cut marks or percussion marks or a combination, but there were 2 marks, G1 and G2, and this is important, that our experts say we don't know what these 2 marks represent. And I will come back to that because it's relevant to the conversation today. But the bottom line of this slide is, not only do we have the V-shaped deep marks containing microstriations, but also 3 experts attributed or identified 12 high confidence percussion or cut marks on those bones. Well, with all that, we went to the cover page of Nature, and that gives you an idea of how prominent that claim was. And we concluded that, number 1, we have now the evidence for stone tool use dating back to 3.4 million years ago, which then would suggest this is a probable evidence for meat eating at 3.4 million years ago using sharp-edged stone tools, which would then suggest, because at Dakika, 3.4 million years ago, we only have 1 species, unless Johannes, I don't know, Deyrameda or Bortelli were hanging out in Dakika. But we only have one species, and that is Australopithecus afarensis. Therefore, this so-called primitive species for us was using stone tools and was engaged in meat-eating and bone marrow consumption, which would then suggest animal tissue consumption using stone tools dates back 800,000 years older than previously thought. Major claim, and we are very well aware of that. But one thing we really underscored heavily is the difference between occurrence and frequency. What we said in our paper is that that behavior of consuming meat using sharp-edged stone tools occurred. We don't know how frequent. That is really a major distinction to be made. But as you can imagine, therefore, once it's published, actually before it is published, some of our colleagues started the conversations, the discourse, and I would put them into categories. Some were very serious and some were less serious. Let's get the less serious out of the way. Some said because they were doing field work for 40 years, not far from our site, they suggested that, oh, they had looked for 4 decades and they would have found them if they were out there. This is, as you would agree, this is flawed scientifically. Well, because not only did we find those cut marks, we also found 3 new species of carnivores, including a giant dog-sized otter. So if you can miss a small donkey, large dog-sized carnivore, then it's very easy to miss a tiny fragment of a cut mark. So this is something that does not hold water, of course. There were also some who suggested this could be marks that were inflicted by crocodile marks. And it is true that we're dealing with fluvial and lacustrine sediments, river system. So this area is infested with carnivores. So statistically speaking, most of the marks that you're going to find at the sites are going to be crocodile marks. So it's not surprising to find croc marks at sediments where you have lakes and rivers infested with crocodiles. But the point is the features, as you can see in crocodile marks, are puncture drag. They also have a different set of microstriations, which is not what you see in the Dikika marks. So we tackled this objectively, and we believe that what we have are cut marks and not crocodile marks. But some were serious, and that serious reply or reaction came from a group of scientists led by Domingos Rodrigo, a Spanish scientist, who I should say has a big and remarkable experience with taphonomy in terms of, so basically we respect this reaction. But there was one problem. In their paper, in reacting to our paper, they used 2 marks that I mentioned, the G1 and the G2, that by our experts, based on our experts, were characterized as non-identifiable. We didn't know what they were. They highlighted those marks in their paper and ignored the 12 high confidence marks. In other words, because these 2 marks for them represented as marks that would be the result of trampling, i.e. maybe animals walked on the bones and then generated that type of mark, they suggested that the cut marks are more likely to be caused by trampling. But they ignored the 12 high confidence marks, including the two marks. This is the 2 marks, I think I should go this way. Yeah, including the 2 marks I mentioned earlier, mark A1 and mark A2. But what is interesting to me is the following. So to back up, so they suggest that the Dikika marks are caused by trampling because the marks G1 and G2 that we said we were not able to attribute to any type of mark, cut mark or percussion mark. Using that, they argued that what we have were caused by trampling mark. But what they say about the 2 high confidence marks, A1, these are the 2 marks on the cover page of Nature, by the way. That is interesting. They say mark A1 and mark A2 are morphologically compelling in their similarity to verified cut marks created by stone tools used in experimental butchery. So they accept them. Let's continue. And they continue to say, the marks show deep V-shaped cross-sections and contain microstriations. That's what we said. They agree. But what they say next is upsetting. They would say, in a less contentious context, the marks would likely be accepted as genuine cut marks. In other words, if this were associated with Homo, if they were 2 million years ago old, they would have been accepted as genuine. I think this is not just a problem with paleoanthropology, but a problem with the scientific method itself. So I would politely disagree with them. So what is the takeaway of our claim? Number one, tool use and tool eating before 2.5 is not surprise, nor is it contentious. Our find enabled us to not only test, but also generate new hypotheses. What we need is rethinking our theoretical framework and really revise how we imagine early hominins were doing on the paleo landscape. And really also remember what John Napier said, or told us in 1962. Modern man, to recover, i.e. we should recover from our surprise at the discovery that hands other than ours were able of shaping tools. I think that is a good point that Napier told us over 50 years ago. But there are reasonable questions, and the question is, what are the tools that were used to inflict these tools? But there is another interesting question, and reasonable, that's what type of tools? Just imagine you were an industrial archaeologist, and your job was to trace the origin and the evolution of phones, telephones. And you know today we have iPhones, and then your job is to go back in time and see whether you can trace the evolution of telephones. You go to the 1800, you can't find the iPhone. What do you say? Do you say they did not have the iPhone, or do you say they did not have the phone? What our colleagues, some of our colleagues are saying is, because you can't find the iPhone here, then there are no phones. No, there were phones, but they were just different phones. In the same way, if you have this type of sophisticated all-do-one tools 2.6 million years ago, what do you expect at 3.4? That's where you should wake up and maybe look for something else. And that's what some of our colleagues did, including Sonia here, who's going to give us more detail. What they found is not all-do-one, but Lamarckian, and there is a good reason for that. What they did is they opened up their eyes. So my point here is to talk about not the cuts per se, but it's important to give that background, but beyond the cuts. The first thing to do is that looking forward, we should look for what is out there and not what we imagine. I think scientists should predict, but the prediction should be predicated upon the data that we have. So let's go out to the sites, even if they are 3 million years ago old or 4 million years old. Let's be open and see what is out there rather than try to find what we imagine. And then we can address the question of whether the equifinality, it's called. Equifinality, many of you know, but it simply means that if you have multiple agents acting on something at the same time, how do you discriminate them? In the case of stone tool, disc marks, cut marks, or any type of bone modification surfaces, if the candidates are hominins, crocodiles, and trampling, what do? Well, you invent new methods. And today we have these techniques called geometric morphometrics, and we can really capture the morphology of those marks in a very objective way, independent of the experts' experience, and put some probability statistics on those values. In other words, the way you capture the shape, rather than say, oh, this is deep, this is in size, this is that, or this is not that, you basically copy that using very sophisticated microscopes. You use geometric morphometrics to characterize the shape, and you put probability statistics on that. And when we did that, actually, this was just presented last week, it appears that the best candidate for the 2 marks that are on the cover page of Nature are statistically hominins and not crocodiles or trampling. So this is how I think we can make our field go forward. In other words, rather than fight about the marks that we have, try to find ways of characterizing the marks in such a way that it's replicable, it's comparable, and geometric morphometrics and the statistics are, I think, more objective than the experts' opinions. So when we did it 10 years ago, it made sense because that's what we had. But going forward, we have to apply these novel techniques and then see what we can say about these marks. We also have to really evaluate our theoretical framework and really generate new hypotheses. And this paper actually published in Current Anthropology just recently. And what we're suggesting there is we have to think of having 2 thresholds when we think of stone tool use and stone tool making. We have to separate the issue of origins of something with what comes later, which is a later elaboration of that specific behavior. Be it a specific anatomy, morphology, or behavior, it just doesn't get born and then becomes the older one. Something would have to happen and then evolve through time. So what may have happened, I think, is we had stone tool use in a rudimentary manner, similar to what you may observe in chimpanzees, but complex tool making would have to come later. And then you would have the hypothesis we're proposing is called the human predatory pattern hypothesis, whereby you would imagine more primitive use of tools, especially in terms of percussion techniques, which would then become later in a more regular cutting techniques that will be elaborated in the future. So putting all that together, we were asked to reflect on who, what, where, and when. And so if you ask me, in terms of the earliest stone tool use and mutating, who did it first? I would say Australopithecus afarensis or Kenyanthropus. They belong to the same grade, based on the evidence that we have today. What did they do? Well, or what did they use? Clearly not the older one, maybe something like the Lamarckian, but clearly we have to look for something else other than that we know. Where did it happen? It happened obviously in Africa, very likely to be in Kenya, Ethiopia, based on the current knowledge. Could it happen in South Africa? Why not? In Namibia? Why not? And when does this happen? Well, at least 3.5 million years ago would be my answer. And with that, I thank you for listening and all of my colleagues who've contributed to making this happen.
Thank you very much, and thank you for the questions, and thank you for the answers. Thank you, Zélé.